This video looks at inequalities on a graph, or inequalities on a grid, sometimes it's referred to as. Basically, we've got our normal graph with our x and x-axis going this way, labelled there, and our y-axis going this way, labelled there. So you can get this drawn out. If you haven't got squared paper, you can use a ruler to measure things out. You shouldn't need to go more than kind of 10 centimeters in either direction, probably a little bit less than that if anything, maybe 7 or 8. And mark all your scales, obviously. And then we're going to look at how we represent things like this. So for example, number 1, x greater than 3, how we would represent this on a graph or on a grid if we were asked to do this. So this is very similar to our number lines, except here we are shading particular regions, and in this case we're going to shade the region we don't want. I'm just going to move this down. So we shade the region we don't want, and we label the region you do want with an R. Okay, so that's how we're going to look at this, just make it nice and clear where our inequalities lie and how that looks on the grid. So x bigger than 3. So for all these inequalities on grids, we're always going to draw the straight line equivalent of our inequality if it were an equation. So by that I mean here we're going to look at the line x equals 3. So forget the inequality for now and let's draw the line where x equals 3. So the line x equals 3 is a dotted line. This could be quite tricky for me to draw, but I will do my best. Is a dotted line through the x value 3. So find your x value 3, which is down here on the x-axis. And then you're going to draw, remember x equals, although the x-axis is a horizontal line, this one, going across here, x equals 3 is a vertical line. Because on a vertical line, every x value will take the value of 3, like 3, 1, 3, 2, 3, 3, etc., etc. So we're going to draw a vertical line through x equals 3. Because this is a strict inequality, there's no equal to, this is a dotted line. A little bit like when we do number lines, we use a closed circle for equal to inequalities like this or like this, and we use an open circle for strict. With graphs, it's the same kind of idea. Again, I'll move this down a little bit. It's the same kind of idea in that for strict inequalities like this, we use a dotted line. And for equal to inequalities, we use a solid line. Okay, so they're the kind of things we need to remember when we're doing this. And you probably want to write this bit away from your graph. Some of mine's starting to encroach on it a little bit, but put it well out of the way. So a dotted line, so it'll look something like this, or a solid line, which will look something like this. So x bigger than 3 will be a dotted line through 3, so we want a dotted line, and you've got your rulers at 3. So we're just drawing the line x equals 3. We're going to make it dotted because it's a strict inequality. There's no equal to, there's no little line underneath the inequality. So this represents all the values bigger than 3. So if you remember when we did this on a number line, we look at an arrow from that all the way for the values bigger than 3. Remember, x values bigger than 3. Here they all are 4, 5, 6, 7, 8, etc., etc. So they're all bigger than 3. So we want this side of the graph. So we're going to label this side R. We know every point here will have an x value bigger than 3, like this, the point 7, 1. The x value is bigger than 3. Okay, this point here, 10, 6. The x value is bigger than 3. Whereas over here, somewhere like this point 1, 5, that x value is not bigger than 3, so it's not in the region we want. So we can always test the points if we want to as well. So we're going to shade, in this case, we would shade nice and neat, again with a ruler, the bit that we don't want. And when we do our shading, I would always shade the full way across the graph. So imagine you had kind of like a box drawn around your axes. Try and shade everything in that box. Okay, that's on the correct side of the line, obviously. So it extends out this way. Okay, try not to stop the line just like there because it's this whole region. Anything this way, this point, -6, -4. The x value is still smaller than 3, so it's the bit we don't want because we want x bigger than 3. And that's how you shade your inequalities on a grid or a graph. Pause the video if you want to get that down. I'm going to rub this off and use the same axes. You can use a different pair of axes so it's nice and clear. I'm going to rub this off, so pause the video if you need to, get it down, and then go on to the next example. So if I get rid of this, and I look at, just keep rubbing these off. And the rest of the dotted line. Okay, so there's x bigger than 3, so that's number 1. Number 2, let's do a smaller than. So let's say x smaller than equal to 1. So same kind of idea. We're going to consider the line x equals 1. So this will be a straight line to the x value of 1, which is here. And this will be a solid line. So this is a bit better for me, hopefully. Can make it a bit neater. Solid line through 1. That's the line x equals 1. And we should probably label our lines. I didn't label the last one, I probably should have done. This is line x equals 1. So we forget the inequality, draw the line x equals 1. We want the values less than or equal to 1. The equal to bit is the fact that it's solid. And we want the region where all these values here are less than 1. So for example, -6, -2 down here, the x value is less than 1. So that's okay, that's in our region. But something over here somewhere like 8 -4, the x value is not less than 1. It's clearly bigger, so that will be in the region we don't want. So we can do our trial point. So we shade the bit we don't want. And again, imagine you've got a box around. You want to try and reach the edges of those boxes and try and get it right up to these lines as well. And this would be the region for x less than or equal to 1. All those values on the left there are all where x is less than or equal to 1. Solid line because it's got the equal to bit underneath. Again, if you want to pause it and have a little think through that and write it down, that's fine, because I'm going to rub it out and use the same axes for number 3. Let's rub that out. So they're both x lines. Let's have a look at number 3. Remember, if you've missed anything, you can always go back and play the video again, or just go backwards and find the bit you've missed. So let's have a look at y greater than or equal to -4. So again, we're going to forget the inequality and we're just going to consider y equals -4. So forget the inequality for now. Y equals -4 is going to be a horizontal line. It's going to be a solid line because it's got the equal to bit. And the line y equals -4, y equals, again, the y-axis is a vertical line, yes, but y equals lines are horizontal lines because every point on this line here has a y coordinate of -4. This one, 3, -4. This one, 5, -4. The y value is always -4. So this is the line y equals -4. And we want the y values to be bigger than that. So we want everything above that line. This point here, 4 -2, the y value is bigger than -4, but somewhere down here, like 2 -6, the y value is less than -4, so not in the bit we want. So we want the bit above the line. So we would label this region with a nice big R above the line, and we would shade the bit we don't want underneath the line like this. There's number 3. Again, pause it if you need to write it down. And then number 4. So let me get rid of this. Let's do y less than 2. So again, we'll ignore the inequality and we draw y equals 2 to start with. It's going to be a dotted line as it's a strict inequality. There's no equal to bit underneath. The difference between the one above, which was solid, equal to bit underneath. Here, no equal to bit, so this will be a dotted line. y equals 2, so that's a horizontal line across at y equals 2. And again, you'll be a bit neater because you'll have a ruler for this. And a pencil, if things go wrong, you can rub it out. So there's my line y equals 2. And I want the values less, where y is less than 2. Well, that's going to be all the values underneath that line. So my big region is here. And I want to shade everything above that line, where y is bigger than 2. Like this point here, 4, 7. The y value is bigger than 2. So I don't want it. It's not in my inequality. But underneath that line, random point, 7 minus 2, the y value is indeed less than 2. Minus 2 is less than 2. So it's in the region I want, hence the non-shaded part. So they're the simple inequalities, where it's just one thing. We can look at combined inequalities as well, and we can look at even slightly more complicated lines, because the line we're drawing are straight lines, so we can start looking at equations or inequalities of this kind of form. If you've been doing your straight lines, you'll recognize that. Again, you're drawing those lines on the graph and then shading particular sides. It gets a little bit more complicated which side you shade when the line gets more complicated, but for these ones like x or y alone, they should be quite straightforward. We're going to have a little look at some combinations, so number 5 next. Pause the video if you need to write this down. I will start rubbing things out. Again, draw yourself a fresh pair of axes, it'll be easier that way. So let's do number 5. So let's look at a combined inequality. So let's look at x sandwiched between -3 and 2. And again, I can think of this in 2 separate ways. On a number line, it would look something like this, where this is at 2 and this is at -3. Open because it's a strict inequality. Closed because it's got the equal to bit, and it's sandwiched. X is between these two values, so between here and here. Same kind of idea on our graph or our grid. So we're going to draw the line x equals 3 for this part. So x equals 3, and it's going to be a dotted line because it's strict inequality. So x equals -3, dotted line through -3. We want x to be bigger than that because we've got the x at the open side of the inequality where the mouth is open. So x bigger than that, so we want all the values this side of that line. But also we want x to be less than or equal to 2. So if we draw a straight line for x equals 2, it's going to look something like this. So there's my line x equals 2, and there's my line x equals -3. All the values sandwiched between that are allowed. So I want x less than or equal to 2. So that's this side, solid line because it's got the equal to bit. I want the values bigger than -3, dotted line because it's not got the equals bit. So I want the bit this side of that line. So I actually want the bit in the middle of this. Okay, just like on a number line. So I'll shade the bit I don't want right up to the line. And this bit I don't want. And then we label this region in the middle with a nice big R. And again, pick a point if you want. 1 minus 2. The x value is 1. Is 1 between -3 and 2? Yes, of course it is, because there's -3. There's 2. 1 is going to be in here somewhere. So it's true, this inequality is correct. Whereas something outside of that, the inequality won't hold. Again, pause it if you want to, write that one down. And then we'll look at a y one, where it's split. So you can get split on the x as well. But let's look at y. So let's look at -2 less than or equal to y less than or equal to 5. So again, I want to consider 2 lines, y equals -2, and y equals 5. The -2 line will be a solid line. Because it's got the equal to bit. And the y equals 5 will be a dotted line because it's strictly less than. And we want y in between these values, so we want the bit in between. I'm running out of time, so I'm going to rush this last bit, but this bit's R. And I shade the bit I don't want, which is this. and the bit I don't want down here, which